All right, now we're rolling. All right. So investigation 2.3, we get into linear equations. How do we make them? So we're going to give you a little scenario here, and we're going to come up with different ways to express different equations for what they need. So our focus today is, what strategies do you use in writing linear equations for linear functions? So again, hopefully it ties into, we can know what the independent and dependent variable is and how to do that. So if you look on your paper that I gave you, Treetop Fun runs adventure sites with zip lines, swings, ropes, ladders, bridges, and trapezes. The company uses mathematical models to relate the number of customers, prices, cost, income, and profit at its many locations. So they use math for lots of different reasons, especially in the business world, right? I always got to know if you're making money or not, right? Because if you're in business to do what? Make money, right? You don't want to lose money. You could go out of business really quick. So it says, when finding an equation, it may help you to calculate the values of the dependent variable for some specific values of the independent variable. Remember, our dependent variable is our y, because it depends on what we plug in for x, right? If x changes, doesn't the dependent variable change? So y is dependent upon x. So note our dependent variable is our x, our dependent variable is our y, our independent variable is our x. So when we refer to them sometimes as that, they'll do it in the book. You got to remember that. You got to know why. So this means x doesn't depend upon, because we can change x, right? It doesn't matter. Y changes when x changes, right? So y needs x, so to speak. And not only that, x becomes before y in the alphabet. So y gets the short end of the stick every time. All right. So let's make an equation here. So it says the standard charge per customer at TTF is $25. So to get in, it's 25 bucks, like Cedar Point, right? Obviously, the way less expensive, because does it cost you 25 bucks to get in Cedar Point? No. So write an equation that relates to daily income I. All right, so they're defining our variables already. I is our income, N is our number of customers. So just at the variables right now, which one do you think depends upon the other one? Which variable depends upon the other one? Elizabeth? Right, this depends upon how many people walk through the door, right? Not the other way around, right? The more people who walk through the door, the more income we would have, right? So how can I write that as an equation with those two variables? Does anyone got an answer for me? Think about a linear equation. How could I write that? Perfect. I, because that's our income, right? Equals 25 times N per customer, right? So if 3 people walk in the door, how much money do I get? $75. And obviously we can use that for 100 people, for 1,000 people, for however many people we want to project that for. So that's our income equation, okay? $25 a head every time walks through the door. Now look at the second cost, the second one. It's the same scenario, but they're asking for something different, aren't they? Each TTF site has operating costs of $500 per day, right? If you go into an amusement park, don't they sell food? Yeah? Do they just make it there, or do they got to go buy it? They got to go buy it, right? They got to pay people to work there, right? So that's the operating costs. So how can I, so it's write an equation that relates the daily profit to the number of customers. I want to give you a little, this is a little acronym that you can learn. Profit is going to equal your income minus expenses. What do you see there? Pi, right? Pi. That's the easiest way to remember it. So we already know what our income is from up above, right? What's our income? Justin, what's our income? 25N, right? So our profit's going to be our income, and then what? We got to add something onto that equation, right? What do we got to add onto that, Anna Maria? What am I going to put? If I just write 500 here, what am I missing? is our expenses added on to our income? Which it's taken away, right? We lose that money because we had to spend some of it. You ever hear the old phrase, you got to spend money to make money? Some of you? Okay. So again, now we can figure out, well, how many people walk through the door that give us a profit? If 10 people walk through the door, this is $250. Do we make money or lose money? Lose, right? Because 500 is bigger than 250 and we're subtracting. So we can now figure out how many people walk through the door for us to make money in a day. So almost the same scenario, but obviously different meaning with the equations, right? Expenses. Here, I'll write it out for you. So profit equals your income minus expenses. We could change it to costs, right? And that could be pick. It's kind of more our language, right? All right. What about number 3? One TTF site bought a new rope bridge. So it's always fun to get new stuff, right? So they paid $4,500 for this bridge. Okay. They'll make monthly payments of $350 until the bill is paid. So they got this big expense, right? They just bought. They're going to make payments on it until it's paid off. So is this number here going to get bigger or smaller as each month goes by? Smaller, right? Because their debt is decreasing. So if my equation, if my two variables are my unpaid balance, B, and my monthly payment, M, which depends upon the other? Does the balance depend upon the month, or does the month depend upon the balance? Which is dependent? Brett? Yeah, because the more months we pay, the less balance we would have, right? So how are we going to make that into an equation? So we know it's B, right? Because that's kind of our Y. See, we still use linear equations. Instead of X and Y, we're using different letters, right? They're still unknown variables. They're just different letters, that's all. So what's going to go first? What are we starting with? $4,500, right? That's the cost of the bridge. So how are we going to add on to that or subtract onto that? We're making monthly payments. And you just told me it was going to get smaller. I do, but I'm using it right now. Can I give it to her later? I'll make a copy. So you told me it was getting smaller, right? So what am I going to add on to it? Anna, you think you know?
Minus 350.
Perfect. So if I want to find out in 8 months what's our balance, what do I do? In 8 months, how much money do we owe? How can I use that equation to figure that out? Right, and then let's solve, right? And the number we got left will be our unpaid balance. Excellent. All right, flip it on over. All right. We've had a lot of experience with tables now, right? And we've spent a lot of time figuring out constant rates of change, finding equations from a table. So now it says one operator of Treetop Franchise suggested the group admission fees in this table. So when large groups come in, all right? So what do we notice here? From 1 to 5, that's going up by what? What's our increase there? 1, right? What do you notice after that? Goes up by 5. So they changed the ratio on us, right? So we'll just see if it still stays constant or not. So we're going to write that in there. Now what about if I go from 1 to 5, what about my dependence now? Do you see anything constant there? Is it going up by the same number every time, Emma? 15? Everyone agree with that? 15? Okay. What about the next 4? So that's going up by 5. What are these guys going up by? From 35 to 210 to 285 to 360. You guys got a calculator right in front of you. You can use it. Ethan. 75. We agree with that? All right. So the first 5, we're going up by basically a 15 to 1 ratio, right? Or 15. Right? So let's see if this is really a linear model. Remember, how do we figure out the constant rate of change? It's the what? What did we learn from the other day going through tables? The change in y over change in x. So 75 over 5 is what? 75 divided by 5. Brett? So it's the same. So really, all they did was, well, once we get to 5, we're going to skip around. This is still, so this table is linear, right? Because it has a what? Constant rate of change. So how can I explain the relationship then between the admission fee for a group and the number of people in the group? How can we write a sentence for that? Come on, we just got done doing a lot of this stuff. We should be really good at it now. You guys are making good sentences last week. As the number of groups increase by the what? Louder. The admission fee increases by $15. So as the number of groups increases by 1, right? And that's groups, not people, right? We don't know if there's 5 people in a group, 10 people in a group, right? That's a group. So 1 group, 2 group, 3 group, right? We don't know the number of people. We just know they're a group of people. The admission fee increases by $15. So they're both increasing. Okay? I know we're pros on this. So if we found our constant rate of change for that table, what's our slope? 15, right? Because it's the same thing, right? Our constant rate of change, or like we could call it the croc, is also our slope. That's 15. Now, we just checked this the other day. How can I find my y-intercept? We don't have a 0 for x, do we? See a 0 up here? Right? So, if we're going this way, sometimes there's downfalls to having the window open. If we're going this way, what are we increasing by every time? 1, right? So how do I go backwards? Subtract 1, right? So if I want to go to 0, don't we just subtract 1 here? So that's our y-intercept, right? We just got to figure out what the y value is. Well, up here, what am I doing? Increasing by. So if I go back, I have to. So what's 75 minus 15? 60. And guess what? There's our y-intercept. So if I want to write it as an equation, and I have my slope, and I have my y-intercept, who's going to tell me what it is? What's our equation? Alyssa. Remember, what's our equation of the line is y equals mx plus b, right? So how can I take this and put it in an equation form? Awesome. That's it. And if we need to, because it says admission fee is A, so we can just change that to A, because that's still our Y, and we could even make that N if we wanted to. It's still the same thing, right? Because they're telling us use A and N. So now we know if we charge, a certain amount of people walk the door, we know how much money we make just through admission fees, the gate costs. Oh, that's a horrible looking dollar sign because my penmanship isn't very good. That's why I don't teach ELA. I tell you guys that all the time, right? Can't spell, can't write. I teach math. All right. Come on, I've said that more than once, right? I mean, no. 5 people already just said yes. Because I can write numbers. All right. That's a debate for another time. All right, we got a graph here, right? Let me ask you a quick question with this. Is that graph linear?
No.
Why? Well, that was a quick no. Why? Because of what?
Because the dots aren't one line.
The dots aren't in one line. You're right. They're all over the place, right? But there are two dots on the line. Are you with me on that? Are you with me? Two dots on the line? Right here and right here. Right? There's a couple that look like they're kind of touching the line, but there's 2 points that we know that the line goes right through the middle. All right? So if we're asked to find the, they want us to find an equation for the snack sales, the income for the snack sales, right? So when I know that 2 points are on the line, how can I find that equation? We just literally checked that 5 seconds ago. All right, we got to find 2 points, right? So we got to find its slope first. So the question is going to be, what are these two coordinates? What's this coordinate right here? Come on. Somebody, the same people keep raising their hand. I want to get some fresh faces involved in this. Michaela, what's this coordinate right here? 1025. Okay, 10, 25, right? And what about the other one? The other point, the top one that touches the line. Nick? 5125, correct. Okay, so if those 2 points are on the line, I can use them to do what? Find my slope. So I'm going to use this one first just because they're bigger numbers. Make sense? Okay. So 125 minus 25 over 50 minus 10. Okay. So what's 125 minus 25, Owen? 100. What's 50 minus 10? 40. Can 10 over 40 reduce? What? Not 1 over. If we divide both these by 10, which is what I think some of you are thinking, what we got? 10 fourths. Okay. Can 10 fourths get reduced further? To what? By 2's, right? Because they're both even numbers? To 5 halves. Okay. So we found our slope, right? What's the other thing we need? Right, so I'm going to erase this a little bit so we can see. So we need our y-intercept, right? Where does the red line hit the y-intercept? 0, right? Right here. So we don't have a y-intercept, right? So what's our equation if we don't have a y-intercept? Zach, what's our equation if we don't have a y-intercept? We write y equals mx plus b. What are we going to write? What's our slope? 5 over 2. So we're going to write, right? Do I have to write plus 0? No, it's not there. So that's my equation. So basically, we basically make $5 for every 2 snacks we sell. That's not a bad deal, right? Basically $2.50 a snack. Okay. All right. Let's flip it over to the back side. You guys are actually going to get some time today to work on the homework. All right. So again, suppose you were asked to write an equation in the form y equals mx plus b. What is our strategy? Well, if we're given a description of a function in words, like we were in the very beginning, right? That first page where we did the income, we did the profit, and we did what we owed. All right? What did we try to do first? What was one of the first things we did? We had to identify something. What did we identify? Those words I told you to note for those new words. Nick? Well, that was an acronym, but X's and Y's are also called what? Brad? Right. So we want to identify the independent which is this is our X, and dependent variables. Right? Once we know our X and Y, it's pretty easy. Then we just have to find what? What else we need to write a linear equation besides our x's and y's? Yeah, we need to find our slope, right? We need to find our slope, or our constant rate of change, which is our m, right? And if it's increasing or decreasing. Right? Going up, going down. We had a couple on the front, right? Two were going, one was going up, so to speak, right? The income, and of course the amount we owed. Remember, that was always decreasing, right? Because we were every month we added, the balance got smaller, right? So suppose we are given two or more values, coordinates, basically, right? So I give you two values, whether so basically points on a table. If I give you a table, how are we gonna find it? Two or more values or a table of values. What do we do on that second page at the very top here? What did we do first? What's the first thing we did? Yeah, we found a constant rate of change, right? Right? That's if we have a table, right? If we have the values, if basically points, right, we have to do what? This. Right? Tables are nicer though, right? We can easily see the table and know if it's constant or not, right? Croc. This? C-R-O-C, croc. Constant rate of change. Constant rate of change. No, there's no reptiles in here. All right, so after we found the constant rate of change, or the slope, what was the second thing we had to find to complete our equation? What's the other piece besides slope? The Y-intercept. So we have to find the Y-intercept. And when we found that by either with two values, right, plugging into y equals mx plus b and solving for b, or in a table, we could actually just count backwards, right? I showed you that little trick, right? We counted backwards. All right, what happens if we're just given a graph showing 2 points? That was basically the thing we just did on the bottom of the last page, right? Well, now we can't really find a constant rate of change because we're given 2 points. What did we do? Right, we had to kind of use this, right? So we had to find our slope. And again, we're going to find our slope using our little formula here. All right. And then for number 2, we had to find the y-intercept. And to find that, we basically had to plug the slope and the coordinate, right, into y equals mx plus b. And solve for b, right? Right? Isn't that how we solve that? Yes, that's how we solved it. All right, so those are the 3 different ways that we've come up with equations. Okay? So, let me shrink this really quick. I want to stop the video. So that was our